This is Algebra 2, Unit 6, Lesson 1, Factoring Review. So in this unit, we're going to be dealing with a lot of factoring. So let's make sure that we understand all the different processes we have and review the ones we know. So the first kind of factoring that we have is reverse distributive. This is when you take out a greatest common factor and then use the distributive law backwards. So if we look at 6x plus 15, your greatest common factor is going to be 3. Factor that out, so divide each of these terms by 3, you end up with 2x plus 5. Remember, this is the reverse distributive law, so you should be able to redistribute and get the same thing back. 3 times 2x is 6x, 3 times 5 is 15. Now remember, your GCF can be a number, or it can be a variable, or it can be both. So if I look at 20x minus 5x squared, your GCF for this is actually going to be 5x. Factor out the 5x, 20x divided by 5x is 4. Negative 5x squared divided by 5x is negative x. And again, you can always remultiply to make sure that you're right. All right, our third one is going to be 8x cubed minus 12x squared plus 20x. GCF, number-wise, is 4, and there's at least one x in each one of these, so this is going to be 4x. Factor out the 4x, you're left with 2x squared minus 3x plus 5. So reverse distributive, basically take out a GCF and divide each term by that, and you're left with a term. The second kind of factoring is difference of squares. All right, it's called difference of squares for a reason. The first thing that you need to notice is that the first term and the last term are both perfect squares. So you have to be able to recognize what the perfect squares are. And also, there must be a subtraction in the middle. Now the pattern for difference of squares, if these are both perfect squares with the minus in the middle, it's only a binomial, so there's only 2 terms. The 2 bubbles are going to be identical except for the signs. So for basically you take the square root of each of the terms. So a squared is actually a times a, goes in the first term. B squared is actually b times b, and it's plus and minus because you want negative b squared and no middle term. So x squared minus 9. Both of these are perfect squares. X squared, 9 and are both perfect squares, minus in the middle. So x and x gives you x squared. 3 and 3 give you 9. And to make this 0 in the middle, it's going to be plus and minus 3x in the middle. So x plus 3x minus 3. Now, order matters when you're doing these, because remember, when you're subtracting, order matters. Same thing when you're doing difference of squares. Notice here, 16 is a perfect square, 81x squared is a perfect square. However, the 16 is first, which means the first term will actually be 4. And then the plus and the minus. And then 81x squared is actually going to be 9x and 9x. Now notice where the 9x is. The 9x and negative 9x have to go at the end, and they're both they end up being negative when you multiply them together. So if you put them in the front, they're not going to be negative. So make sure that you do that. So order matters when you're subtracting. Okay, so let's throw in a fraction just to make life interesting. If we have 4 over 81x squared minus 49 over 9. So people freak out when they see fractions. This is not a reason to freak out. Look at each part of the fraction. The numerator, 4, perfect square. Denominator, 81, perfect square. X squared is a perfect square. 49 in the numerator is a perfect square, and so is 9. So this is difference of squares. There's a minus in the middle. So let's break it down individually. The first one's going to be a fraction, so that means we have a fraction in the first term. For the numerator, how do you get 4? Well, in the numerator, 4 is actually 2 times 2. In the denominator, how do you get 81? 9 times 9. We know it's going to be x and x to get the x squared. There's your first term. So it's actually 2 ninths x times 2 ninths x. Plus and minus in the middle. Now for the other fraction, we have 49. Well, 49 is 7 times 7. And for 9, it's 3 times 3. So look at that. We just did fractions as perfect squares. So when you split this up, just do the numerator and denominator individually. Look for the perfect squares. All right, our last one. This one's a little sneaky. 4x squared plus 25. Now, it's really tempting to just say this is 2x plus 5, 2x minus 5, but it's actually not. Why not? It's because of this. Even though 4x squared and 25 are perfect squares, because of the sign, this is actually the sum of squares. The sum of squares does not factor because of the plus sign. What happens is, if you have the plus there, it is going to give you a middle term. So this does not factor by difference of squares. So that is difference of squares, perfect squares on the end, minus in the middle, usually a binomial. The third kind of factoring that we run into is factoring trinomials, which are three-term polynomials, 1, 2, 3. We usually use either double bubble or the box method. I don't care which one you use, whichever one makes you happy, and you get the right answer. So I'll do both at the same time so you can see where I'm getting the numbers from. So double bubble or the box method, x squared goes here. All right, that's to get the first term in the bubbles. So how do you get x squared? It's got to be x times x. We know that's going to go here. Okay, now sign-wise, this is positive, positive, so we know this is going to be plus and plus out here. Now, your end term here is 24, which would be where these two factors right here go. We need the factors of 24, but they have to add up to 11 in the middle. So what factors of 24 give you 11? Well, it would be 8 and 3. It's going to be neither one. So this is going to be 8x and 3x added together gives you 11x. So this is actually x plus 8, x plus 3, or you can do the double bubbles right here. These two terms give you 8x and 3x right there. So 8x plus 8, x plus 3. All right, be careful of your signs when you do these. If you're doing the box or the bubble, whichever one, make sure you know what signs you have to use. X squared goes here. That gives you x times x. That's the first term in each bubble. Okay, now since this is positive, that tells me the signs have got to be the same, but this is actually negative 13. So it's actually got to be negative, negative. So both of these have got to be negative, goes on the outside, it goes as minus, minus in the bubbles. All right, 22 goes here. So the factors of 22 that are both negative that give you 13, well, 11 times 2 is 22. So negative 11 and negative 2 should give you negative 22. If I multiply this out, I get negative 11x, negative 2x, added together gives me negative 13. So this is actually x minus 11, x minus 2. And our final one here, x squared minus 5x minus 50. All right, here's my box, and here's my bubbles. So x squared is actually x times x. That's going to go in the first term. Okay, negative 50 means the signs are going to be opposite, so I've got to figure out my factors of 50 to give me negative 5. Well, I know 10 times 5 is 50, but to be negative, this would have to be negative 10 and positive 5. So when I multiply this, I get negative 10x, positive 5x. When I add those together, I do get negative 5. So watch your signs. We end up with x minus 10, x plus 5. All right, so that's factoring trinomials using double bubble or the box method. Now, these were all trinomials that have 1 as your leading coefficient, so just x squared. What if you have larger trinomials, like 3x squared, or 4x squared, or 6x squared? You can still use the box method or double bubble. So we're going to focus on double bubble first, and then we'll do the box method. So if we are using double bubble, it's helpful to think about the structure of the factors in order to make intelligent choices. Sometimes you want to put in as much as you can and then figure out what you can use and what you can't. So let's deal with double bubble here. Okay, so 3x squared. The only way to get 3x squared is 3x times x. So that is my first term. It has to be. Okay, now for my last term, I have different choices. I have 40 is 1 times 40, 2 times 20, 4 times 10, and 5 times 8. So I have 4 choices there. Let's see if I can eliminate some of them. Well, this has got to be negative 40. Whatever goes over here and goes into the left spot, or the right spot right here, has to be multiplied by 3x for the outside inside. All right, so we have to make sure one is plus and one is minus, and they have to add up to 19. So whatever goes here is multiplied by 3, added to this one has to be 19. So would 1 and 40 be a good choice for one of these if one's multiplied by 3? Probably not. So that's probably too big. 2 and 20? Well, 20 is not far from 19, but I'm going to have to multiply the other term by 3, so that's probably not going to work either. Okay, 4 and 10 might work if I put them in the right place. Let's see. If I do 3 times 4 is 12, but that would give me 10 over here, that's not going to work. And if I switch them around, that's going to be way too big, because that'll be 30 and 4. So 4 and 10 is not going to work, so that leaves me with 5 and 8. Now, if I want this to be 5 or 8, I would have to probably do 8 over here and 5 here, because that gives me 24x and 5x. And to get this to be positive, 24 would have to be positive, which makes the 8 positive, and then minus the 5. So 3x minus 5x plus 8 to get that to work. All right, now where it gets a little complicated is when there's more than one factor that you could use. 4x squared could actually be 4x times x, or it could be 2x times 2x. And on the other end, 6 could be 1 times 6 or 2 times 3. So I've got two options to use, and I've got to make sure they work. So let's see if I can do a little thought first. 4x squared plus 5x minus 6, does that have a GCF? It doesn't. So if I use 2x and 2x here, and I use one of these, at least one of these would have to have a GCF if I use 2x and 2x, because 6 divides by 2 and so does 2, so I can't use 2x and 2x. However, I could use, that leaves me with 4x and x, so that gets me some choices down. All right, now remember, whatever goes on the end term has to be multiplied by 4. So whatever I put here has to be multiplied by 4 and then added here. So probably 1 and 6 isn't going to work because that would be too big. You got to want it to be 5. But 2 and 3 might work. Now, if I put the 2 here, would that make sense? No, because if I put the 2 here, that's going to give me a GCF. So I don't want a 2 there, so I probably want to put the 2 over here. And then the 3 here. So that gives me 3x and 8x, which I can get 5 by making the 3 negative and the 2 positive, so I get positive 8. So that works out. So think about your choices when you do that. All right, the last of the double bubble ones here. We have 6x squared minus 13x plus 6. All right, so I have 1 and 6, or 6x and 1x, and 2x and 3x on this end, and 1 and 6 and 2 and 3 on the other. Now, your signs on this one, notice this is plus, and this is negative, so this has got to be minus minus. So I can put that in immediately. All right, now, I need to get negative 13 in the middle. Would 6 and 1 be useful on this? Probably not, because if I use 6 and 1, all of these are going to be really, really big. And at least one of the factors will be bigger than 13. So we want something a little less than 13. So probably 6 and 1 is not going to work. So that leaves me with 3x and 2x. Okay, when I set up my terms here, 1 and 6 and 2 and 3. All right, now again, I have to multiply 1 by 2 and 1 by 3, so probably 1 and 6 isn't going to work. But if I use 2 and 3, would I put 3 here? No, because that'll give me a GCF in this group. So let me put the 3 over here. And the same thing if I put the 2 over here would give me a GCF. So if I switch those around, that gives me negative 4x and negative 9x, which handily enough does give me negative 13x. So think about your factors when you're doing these for intelligent choices. Okay, now the other method of doing trinomials is the box method. The 3 that we just did by double bubble can also be done by the box method, and some people might find that easier. So it just depends which one you want to use. But if we're going to use the box method, your calculator can really help you when you're trying to do your factors. Okay, so with the box method, we set it up just like we did with the other trinomials, but there's one more step. Because this is a bigger trinomial, the leading coefficient's more than 1, we actually have to multiply these two terms together, which is negative 300x squared. Okay, so then I need the factors of negative 300 that will add up to be 13. So if I look at my calculator, that can help me figure it out. All right, so if I go to y equals, I want negative 300 divided by x. Okay, now I need to look at my table. There's my table. Now that's a lot of factors when I do this, so I need to figure out which one is going to add up to be positive 13. Well, you might be able to pick it out from this group if you look at your values. But if you want to verify that it is, if you go to y equals again, you can even put in the same negative 300 divided by x, and then add another x to it. Oops, add x to it, sorry. What that'll do is that'll add the x column and the y column together, because this is the same thing as in y. And if we look at this column, which one, and the red y column, which comes out to be 13, is 25 and negative 12. All right, so 25x and negative 12x will give me 13. So 25x goes here, negative 12x goes here. Now we want to do the GCF of each row and column. Up and down between the 10x squared and the 25x is 5x, and across here would be 2x. All right, across the bottom would be plus 5, and up and down here both negative. This would be negative 6 is your GCF. So your answer is going to be 2x plus 5, 5x minus 6. Okay, we'll finish up the rest of these in class the next day.